For this next lesson, what I'd like you to do is I want you to recall how we dealt with data in the past. And to do this, to store information, we essentially created a primitive variable of one of 5 types: int, string, bool, double, or byte. And using these different types of containers or buckets, we essentially were able to store pretty much anything we want. Now, the problem is the way our programs have been so far, they've been very simplistic. Bring in some data from the user, calculate some simple result, and then store it and then display it onto the screen. Now it's fine, except in reality most programs deal with a large amount of data, and simple buckets can sometimes be inefficient or insufficient. So what we need to do is we need to figure out ways to deal with large amounts of data in a simple way. So let me give you a quick analogy. Imagine you're creating a program that manipulated student marks in order to store them, as well as calculate areas, or sorry, not areas, averages and whatnot. So to do this, you would essentially need a separate bucket for each student. Now, the average class has about 30 students. So if we had 30 buckets, that's a lot of variables. And then every time you wanted to change those buckets, you'd have to go to the right bucket and make sure you knew which bucket to talk about, which could be very cumbersome, because how do you know which bucket is which? You'd have a whole series of if-else if statements just to make sure you access the correct bucket every single time. Okay, so how do we actually handle this? How do we simplify this for large amounts of data? Well, most programming languages, C# included, include a special mechanism, data structure, in order to store large amounts of related data. So instead of having separate buckets, it essentially has one big bucket with a whole bunch of dividers in between. I put this little dot 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 to represent the fact that we have 30 of these buckets here, to represent the same analogy we had a second ago. Now, what is in each of those buckets? Well, each one of these buckets is the same thing as one of these separate buckets. But what we've done is we brought it under one collection. So it only has one name. We don't have 30 separate names. So this might be, in reality over here, we might have Mark 1 and then Mark 2 and so on and so forth. Instead of having that, we could just simply have this array and call it marks. Simplifies things quite a bit. We could have a whole bunch of data inside of this array. Let's say we have a 90, an 84, a 75, an 82, and so on and so forth. Now, where the problem comes in is how we handle and manipulate this data. Now, if we wanted to put a 90 in Mark 1 over here, it's very simple. Once we have the variable created, we would just say something like Mark 1 is equal to 90. There's not a problem there. However, when we're dealing with the array, we can't do the same thing. We can't just say marks equals 90, because how do we know which one we're talking about? Are we talking about that one, that one, that one, and so on and so forth? We don't know which element of the array we're talking about. And when I say element, what I mean is one of the individual buckets. Each one is called an element. So for example, if I ask you what is the value at the third element of the array, you would tell me 1, 2, 3, 75. 75 is the value at the third element. All right. So what we're going to do for the next few modules is really figure out how to change, manipulate, and work with this data to hopefully simplify our lives as programmers.